Okay, so we want to look at calculating for molar masses of some given compounds. This afternoon, and I wouldn't want to talk too much. Calculating for molar masses of some given compounds, and KLBU. I've been doing this. When you see me giving you this, it means that questions for better understanding. So quickly, number one, calculate for the molar mass of the following compounds. So number A, we're going to calculate for the molar mass of sodium chloride. Sodium carbonate, you have sodium hydroxide, ammonia, water, and then carbon dioxide. This is ethanoic acid. But before you do that, they need to give you what we call relative atomic masses of each element present in a given compounds. Relative atomic masses, we'll talk on that, but the values are: sodium is 23, chlorine is actually 35.5, let's have carbon 12, oxygen is actually 16. What again? Hydrogen is 1, of course, and then nitrogen x 14. I think we have all of them. Let's look at that. Well, we have them. Well, even if we don't have it, when we get there, I'll give it to you. So to calculate for molar masses, you need the relative atomic masses. I'll explain that later. So let's start. Good. But before we start, there is something also you want to know, or you have to know before you fully understand how to calculate for molar masses of some given compounds. And what is that? So wait for me. So you will need to understand what we call the term atomicity. Here, atomicity. So here I've given you 1 to 5, compounds or molecules, for we to understand what we mean by saying atomicity. So let's look at atomicity of this compound. But what is atomicity? Simply the number of atoms, the number of atoms. Like here you have in this molecule or a compound, you have hydrogen, you have chlorine. These are actually the elements. But when we are talking of atomicity, the number of atoms present in a given molecule, perhaps also present in a compound. So to not talk too much, the atomicity of the this compound, we start mentioning the atomicity of each. So atomicity of hydrogen here is actually S1 because it's only one hydrogen there present. What about chlorine? Chlorine is also 1, according to this. Now, if I ask you the total atomicity of this is hydrogen chloride, what will be its total? Yes, can you say it? Total, total is just adding the 2. So let me just represent T to be total, and that means that the total is going to be 2. Therefore, the atomicity of the whole hydrogen chloride is 2. What about water here? Now we have the elements or the atoms present here. You have hydrogen. What is it? Atomicity there. 2. Oxygen. Beautiful. What is this atomicity? 1. Can you tell me the total? The total is what? 3. Atomicity of that is 3. So now quickly, hydrogen here is 2. You have sulfur. How many? 1. That is atomicity. You have oxygen present. 4. Great. Now, can you tell me the total? Check it. What is that? 7. right? Can you tell me the atomicity of the last two? Let me give you about, some seconds and work out. I'm waiting for you. Great, right? So what did you get? Now, if you did it well, you will get the atomicity of what is here, carbon. So carbon 1, according to that. Oxygen present in there, this is carbon dioxide, oxygen there, the atomicity is what? 2. Total, did you get it? Did you get it? So the total is also what? 3. Then what about this? What is that? The atomicity, we have carbon present, 6. Hydrogen, very simple, 12, that is the atomicity. Then the last is what? Oxygen here is 6. Can you tell me the atomicity of the whole this compound? I think this is glucose. What is the total atomicity? What is that? This plus that is actually 18 plus this 24. So it means that the atomicity of the whole this is 24. The whole this is what? 3, that is 7. That is what? 3, and this is what? That. All surfacing or coming from the very atoms or the element present in there. So you sum them to get the atomicity. But you see, this is not what I'm teaching. I said that for you to be able to understand how to do what, calculate for molar masses, you need to understand atomicity. Hence, let's go back. So we're going back to our calculation of what? Molar what? Masses. And so here we can start. Let's start. So let me give you answers. Answer. Number 1, that is it. What's number 1? So number 1 is that. Calculate for the molar mass of the following compound. I said number 1, but it's actually A. Then the symbol for molar mass is actually capital M. We also have relative molecular mass. I'll explain that. So the molar mass, check it, of what is that compound? Sodium chloride, right, is equal to, I hope you are paying huge attention, because I'll give you, I will work out for only 3 of them, and the rest you will solve it. So you have to pay huge attention, right? So let's begin. Molar mass of sodium chloride. How do you do that? So you begin by writing the atomicity, the elements here. You have sodium and chlorine present in this compound. And so what is sodium's atomicity? That's how you begin. Atomicity of sodium is just 1. Then you simply multiply by the relative atomic mass of sodium. What is that? What is that? Is given. You'll be given that 23. You close it. Plus you go to the next element. The atomicity there, how many there are here? Chlorine, 1. Atomicity is 1. Multiply by its relative atomic mass. Chlorine relative atomic mass is 35.5. Simplify that. 23 plus 35.5. What the final answer? What is just that? Computed 58.5, and the unit of molar mass is simply what? Grams per mole. That is the unit. Are you okay? Is it difficult? No, it's not. Then we go to B. B aspect of that. B. What compound is there? Sodium carbonate. So the molar mass of sodium carbonate. Shall we start? Sodium atomicity 2. Very simple. Then relative atomic mass of sodium again, 23. Plus, you go to what? Carbon. What is this atomicity? Is just 1. Then the relative atomic mass, 12. Plus, we come to oxygen atomicity. What is that? 3. What is it? Relative atomic mass is actually 16. Sorry. Then the total there, when you do what is just that, here is 46. Well, you could write the answer straightforward, if you like, and here is 12. The 3 by this is 48, and the total answer, when you do it well, is this. Now, this grams per mole, let me also use this star, is the same. This grams per mole, that, according to indices, is the same. So that is that. I'm going to solve for the last one, and that will be the end. You go and solve the rest. That is option. Well, which one would you want me to consider? These. Which ones? We'll solve for this and that. Which one do you like? Which one? You say what? No, I wouldn't solve for the G. This is ethanoic acid, because the rest are so simple, and I wouldn't solve for this. Well, let me consider the carbon 4 oxide, and that is option what? F. Shall we start? Molar mass. Can you see? All right, so molar mass of carbon 4 oxide, commonly we call the carbon dioxide, is equal to carbon, whose atomicity here, yes, and the relative atomic mass is that. Good. And of course, oxygen, here we come to oxygen, whose atomicity first multiplied by is what? Relative atomic mass is 12. Perfect. Right, so this is equal to, that is 12 cross, this is what? 20 what? 4. So what is the final answer? What is just that? Is that true, what I have done? Yes. 212 is, I think I'm not getting something right here. Yeah, the oxygen is actually 16. I'm sorry for that, 16. And so here you're going to get 32. I think it's better to cancel this nicely. And 12 plus, so that is 32. And the final answer here is 44 grams per, let me use the star, mole. That's it. So the rest then will be what? This, what we call ethanoic acid. You're going to solve for this one is ammonia and that of water. So that is your assignment. The next time we meet, we'll reconsider that, and we'll address the answers to see those who can get the answer correct. Right? So God bless you. We shall meet the next time. Bye-bye.